There we go. Okay, so I am a software engineer at Zeus Health. And I think the most important thing you should remember about our company is that it is pronounced Zeus, not Zus. And you might notice that James is in this photo here. Actually, one reason is because I couldn't find a better photo of myself, but another reason is because James actually helped us a lot in understanding the GraphQL on FHIR spec. So he deserves a shout out here. Thank you, James. So learning objectives for today, I think everyone can go ahead and read the points on this slide. But one thing I want to say is that an advantage of presenting on the last day of DevDays is that I had the opportunity to hear a lot of very dynamic discussions in the FHIR community. And I think that for today, this is not so much, we're not showing off what we're doing or like telling you how to live your life. I think this is more about an opportunity to invite discussion and feedback on our approach to GraphQL. So I want everyone to not take our word as like the truth, but just as a data point of how to implement GraphQL on FHIR. And this is focused on read-only use cases. I'll make a little bit of a remark about writes, but this is mostly about read. And so in observing the users of our platform, for reading FHIR data, I think that we can group the use cases that I know about into two broad categories. There's interactive use cases and bulk use cases. And maybe there's something I don't know about, but I think in general, you can almost group everything into interactive versus bulk. So interactive is something like, I just want to browse like the 10 patient resources and see what they look like. I want to get a sense of what my data looks like. And then one is building interactive end user applications. And I'll show an example of one. And then the other types of use cases are like, I want to know how many patients have X condition, right, in my entire sample, or I just want to sync all my data to my server. And these are all bulk use cases. And so for the APIs that I want to talk about today, we're focusing on the interactive use cases. So here's a screenshot of one of our sort of signature applications. You can see that this is a view of one patient profile. And in the patient profile, you want to look at like a list of conditions, and for each condition, you want to look at just a certain part of the condition. And so for this kind of use case, you want something that's very quick. You want your application to be responsive, and when I click around and when I look at the allergies or the care teams, I want everything to respond very fast. And I don't want a huge list of care teams. I just want the top ones that I can kind of get a sense of what this patient is going through. And so these are applications that require something very responsive and interactive. So with the FHIR API, there's two flavors of it in general. The REST API is the one that everyone kind of knows a lot more about. It's been around for a long time. It's very standard. And GraphQL is still in a draft. If you go to the web page for the FHIR GraphQL spec, it will actually say this is a draft. And here's an example of a RESTful API. I'm sure everyone here is very familiar with it, but I'm still going to go through. This is a very typical request that our applications will be making. We want to find allergy intolerances for a patient with a certain identifier. And so you'll notice that this is a change search. This is not just like the patient ID. So this will have to actually go through the patient and get the identifier on the patient. On our applications, we'll typically want something like the latest allergy intolerances or the latest conditions or something. We will want a certain number of them, and our applications also like to display, in this particular instance, we want to know which organization was responsible for creating this, or is associated with this allergy intolerance that came back. And so we have both include, this comes back with a patient resource, and include iterate, which comes back with the organization resource associated with the patient resource associated with the allergy intolerance. And the response comes back with your allergy intolerance resources as well as your patient resources and the organization that is tied to this. And so I think everyone here is very familiar with the REST API, probably very familiar with the advantages. It's standardized. There's a lot of libraries you can use, and the sort of request response syntax is very simple and predictable. You just like put in a URL and you kind of know exactly like what you get back, because you can just go to the documentation and see, oh, here are the fields that are going to come back. There are also, of course, limitations, and these limitations, a lot of these limitations were elicited from us talking to our primary users, which were the people who were building these interactive applications. One of the interesting pieces of feedback that we got was that when you make a request like the one that I was just showing, you have a bundle that has your allergy intolerances with a reference to a patient, and then you have the patient with that ID, and then you have the organization with the ID. And they had to do all this work on the front end to associate the patient with the allergy intolerance and the organization with the patient, because you have a whole list of many of these resources. And then another thing that is more obvious is that the resources that come back will include a huge amount of data, because that's just the standard default that comes back, and then there's a lot of mandatory fields. Sometimes you can use the elements parameter, but there are mandatory fields that come back, and then no matter what your response, it's always going to be above a certain size, and if you are very limited on bandwidth, you probably don't want that. And another piece of feedback we got was that on these very interactive applications, they wanted to perform OR searches. They wanted, especially OR searches between search parameters that had nothing to do with each other. So for example, I want like a condition with a certain status, but that condition might also have some date. And I want to OR these together, not AND them together. And what they would end up doing is they would make two queries and then kind of deduplicate research on the front end. Oh, and then I forgot to mention, there is an underscore filter parameter where you can do these, but supporting this on the server side is actually very complicated, so we haven't allowed that yet. So here is a GraphQL example of the same example from the REST API that I was showing earlier. So we want allergy intolerance. You can notice that here we are using the underscore filter. This is just an example. We haven't actually implemented this. But this is how you would have to do an OR query in GraphQL. If you look at the spec, it says this is what you have to do, because they don't otherwise support chained references. But you can see that in order to get the patient and the managing organization associated with the allergy intolerance, you just put in fragments. And the reason you have to put in fragments is because, actually, I apologize, this slide is a little bit inaccurate. The patient is a patient resource, so you don't have to do the fragment here. The fragment is when your reference might be different types. And so you have to say, if it's an organization, then I want these fields. And the nice thing about this is that you then get your patient and organization in the same entry within your response, instead of in separate responses, and you have to like stitch them together. One thing you can notice about this is that there is no real support for pagination with this particular request. So you can get 250 results back, and then that's it. You can't really get the next page. So there's another type of GraphQL request that's in the spec, which is the connection. And in the connection, you can put in previous and next. You have to ask the server to give you the previous and next values. And the server will then give you a cursor, which you can then pass in your next request. So this is how pagination is done with GraphQL. So you can see that some of the advantages of GraphQL over REST is that the graph structure is very natural for, FHIR is very much a graph structure. And so the whole effort you have to go into to stitch things together is much easier when your response comes back in a graph. Also, the other problem that I mentioned earlier, where your response comes back with all these fields in the REST API that you might not want. GraphQL is a better fit if you really don't want all these fields and you only have a certain number of fields that you want. You just say, I want this in this field, and then I get this in this field back. And another cool thing about GraphQL is that there's the introspection API. So if you are somebody who comes in from another GraphQL background, you are very familiar with the introspection API, you can just go to the introspection endpoint and get you can kind of just navigate the fields, types that are available automatically. And if you don't want to ever look at the documentation, you can just look at the introspection endpoint. So that's one of the cool things about GraphQL. Of course, there are a lot of limitations as well, and I think the main one is that you have to know exactly what you want back. And actually this morning, one of the engineers on one of the application teams was asking like, oh, what if I just want all the fields back? And I was like, I think you want a REST API. Yeah, so if you are using GraphQL, you have to, if you want the entire patient resource, you just have to pass every single field in the patient resource to get them all back. So you have to know which, if REST is actually a better fit for you, then just go for REST. And if you are an implementer of GraphQL, then you might realize that logging is kind of complicated because with the REST API, you can just see like all of the parameters in their GET request or in the URL, so you know exactly what they're searching for. With GraphQL, they're all post requests, so it's a little more, and the post requests have these very complicated structures potentially, and so it's a little harder to just analyze your logs and understand the trends and what people are looking for. And these last things are, the ones that are kind of a different color, are specific to the FHIR GraphQL spec, which is that the GraphQL spec on FHIR is still a draft. There is some missing guidance in it, actually. And you might see that as a pro or a con. In our case, we try to take full advantage of this. So if you are thinking of implementing GraphQL, there are some things you want to think about, like the things that we mentioned before. Do you really want, is it really important to you to be able to get back a tiny response? Is it very important to you that the response really reflects the graph structure? And if you are like us, there are some things about the FHIR API that your customers might have said, oh, this really doesn't work for us, can you come up with a better solution? And you might look at the FHIR GraphQL spec and go, maybe we can do something that is not totally standard and see how that works out. All right, so we're going to go into our experience of implementing a GraphQL server. And this is just, again, one data point. This is not the way to implement it. This is what we chose to do. We are a Go shop, so we had to write our server in Go, and we use GQLGen. This is a tool that not only hosts your GraphQL server, but also allows you to generate the code that runs the server. And so we actually did a lot of code generation, and that actually affects a lot of our choices in how we implement the spec. And then just for the nerds out there who want to understand how we store data, we use DynamoDB as the storage, mainly because of horizontal scalability. We did consider a lot of other backends. We considered, I think, Mongo, and then dgraph is a very interesting database because it's GraphQL native. Essentially with dgraph, if you just like stick resource, or if you just stick your data into it in the right structure, it automatically serves GraphQL. So it's very cool. But in the end, we still went with DynamoDB because we really wanted to bank on the scalability of it. And then for the API syntax, again, because GraphQL's FHIR spec is still a draft, there are certain pieces of guidance that we found missing, and in those cases and then there are some other cases where we thought the spec didn't really suit our needs, and so we started with the spec as a basis, and then if we found things that we wanted to change, we would just modify those. And I would love to hear feedback for any choices we made that were really weird, or if you think that's a great idea, and we can push it further. So some implementation challenges we ran into were with how FHIR represents things. I think one of the things that people always find challenging with the FHIR spec is various types of polymorphism. So there's two types. There's the choice types where you have a value bracket X, where it could be value string, value integer, value whatever. And representing that in GraphQL, on the client side, if you're writing your GraphQL client, you have to end up requesting all of the possible types if you want, sort of complete data. And then the other type of polymorphism is when your reference could be different types. So the example that we like is on the patient, you have a general practitioner, and that could be an organization, it could be a practitioner, it could be a practitioner role. And if you are a client and you want the data, regardless of what type it is, you have to then use these fragments. And in each fragment, you have to know what field you want. And finally, there are these cases where the different types have the same name, the same field name. So for example, organization has a name, and practitioner has a name. But on the organization, the name is a string. And on practitioner, the name is a human name, which is a struct. And if you just request that straight out, did my microphone go out? Okay, sorry. So if you just directly request name on both organization and practitioner, GraphQL is going to complain and say the type is different. We can't return this result. And so what you have to do is you have to alias these so that they come back as different fields in your response. So there's something that, these are all things that we learned the hard way, so we're sharing that. On the server side, when we're implementing the schema, for these choice types, we then have to create an optional field for each of these. So this is kind of different from the, if you look at the FHIR spec, it will say that you need exactly one of these. You can't have both. But in the GraphQL spec, you have to kind of relax that a little, make all of these optional fields. And for polymorphic references, there are two ways to do this, or at least two ways that we know of. One is that you can explicitly union all the types together. You can create a type that's a union, and then use that union in your patient schema. Another way is that you just have a generic type that we call it reference, and this represents all the possible resource types. The union type is probably better because what happens is that if you are a client and you write general practitioner and you try to request something that doesn't make sense, like claim, then that doesn't work. The GraphQL server will tell you that doesn't work. Whereas if you have a generic type like reference, and somebody says something doesn't make sense, like I want patient, I want general practitioner, and then like ... on claim, the server will be totally happy. It'll just give you a blank result back. The problem with the more explicit implementation was that, remember, we generate our code. And so we were generating a huge amount of code for all of these unions, and we generated so much code at one point that it wouldn't compile. We just had too much code. And so we ended up using the more generic reference type for these polymorphic references. So again, this was like based on our choice of code. So if you use a different tool for generating your schemas, maybe you won't run into this problem. And on the adoption side, we realized that people had some FHIR parsers that they were using already, and initially we were like, oh yeah, like if you just request all the fields on each resource type, then you can use your FHIR parser. It'll continue to work. And we realized quickly that there were some exceptions to this. One is that there are empty fields. GraphQL can return empty fields, and in FHIR, empty fields are not allowed. So that was the first thing we ran into, and we had a team that was using the Google protobuf parsers for FHIR, and they said, hey, our parsers are blowing up because you're returning all these empty fields that we requested. And we were like, oh, okay, well, we will return resources that are FHIR compliant, so we'll suppress all these empty fields. So we started suppressing all the empty fields, and we realized that introspection broke because there are all these introspection tools for GraphQL that automatically will retrieve the spec, and we were suppressing empty fields on that. And we went back and forth on this and decided empty fields are more compliant with GraphQL. We're going to go with GraphQL. We will return empty fields. So for the people who are using these protobuf parsers that are really strict, sorry, you just have to like modify your parser. And the team that was doing that was like, okay, fine, we understand. The next thing we ran into was, of course, these reference fields that come back in the reference types. In the actual GraphQL and FHIR spec, it does say that you put in a resource field. And so if you have a strict FHIR parser that's expecting certain fields out of like general practitioner, and you get resource back, that's not part of the spec, right? So if you have a FHIR parser that doesn't expect extra fields, this isn't going to work. You have to also expect a resource field. And then another thing that I mentioned before is if you have different types with the same, or different resource types that have the same field name, like organization has name and practitioner has name, and they're different types, you have to alias them. And so once you alias the field, it's going to come back in a field name that isn't part of the FHIR spec. So you have to modify your FHIR parser if that's what you're using. And I found this quote on Zulip where Graham said, GraphQL output is not FHIR resources. So I think that's a very succinct description of this. So I'm going to talk about some of the decisions we made in terms of implementing how our API is going to look, and some of the decisions where we kind of deviate a little bit from the spec. So in talking to our potential users, one of the things that we were concerned with was, what kind of search parameters do you want? And it turns out they don't want that many. There's like a very fixed number of search parameters that they are actually using. And in our case, the ones that were really important were like patient.identifier, which was a chain search. And for Zeus, we have, I'm kind of playing the hand wave around this, where our access control is kind of our special sauce. And so we have these scopes that are very specific to our access control. And so that is going to be a big part of our search parameters. And that's kind of a custom thing. And then we had implementers or like application developers who were saying like that the OR searches are very, like they would really like them, but it's kind of okay, it's a nice to have, because they can always make these two requests and dedupe on the front end. And so that's something that we are thinking of in the next version, but not right away. On sorting, I noticed that the GraphQL on FHIR spec doesn't contain the word sort or order in any way, so it seems to be missing from the spec, and I'm not sure if that's intentional. But in any case, we wanted to sort things, and so we also had to go and ask our users, what do you want to sort by? And it seems like one thing that we notice is the things that people want to sort by and the things people want to search by are not necessarily the same. But in the FHIR spec, I think the search parameters are used for both cases. So there's kind of a question of, are FHIR search parameters really supposed to couple sort parameters and search parameters? Because in my mind, it seems pretty separate. So on pagination, there are a number of different types of ways people will paginate, but the one that seems most common is this GraphQL cursor connection spec, which there's an actual spec for it. It's actually very similar to the connection documentation that's on the FHIR spec, but there's some subtle differences. The FHIR spec uses different parameter names, so they use _count, and the GraphQL cursor connection spec uses these, like first, after, last, before. Another thing is that if you look at the GraphQL spec for FHIR, they put first, previous, next, and last on the top level of the parameters they can request, whereas in the GraphQL cursor connection spec, they have a special element called page info, which contains all of the pagination data. And so for us, we had to ask ourselves, well, do we want to follow the FHIR one, or do we want to follow this GraphQL cursor connection spec that seems more common in other GraphQL implementations? And again, we opted for GraphQL because we actually had a lot of software engineers coming in from other domains that are not healthcare who were already familiar with GraphQL but not as familiar with FHIR, and so we kind of lent a preference towards the more GraphQL native approach. So here's just a summary of all things that we decided. For search parameters, we introduced our own scope for access control. For sorting, we just added our own argument because it wasn't really there in the spec. For pagination, we adopted the GraphQL version. And in terms of which filter and sort parameters, we just implemented the ones that we wanted, and we didn't like really try to support anything else. And then for filtering, we also, for the sort of and or not syntax, or sorry, I mentioned that people wanted or searches, and so we decided to try to adopt this and or not search parameter syntax from dgraph. So we actually were very inspired by their syntax. So if you look at our search syntax, we have this filter parameter which is nothing like what the FHIR spec has. And this is very much inspired by dgraph. So we have these are the elements that you can filter on, and then we use predicates. And in a future version, we're probably going to add Boolean predicates, or Boolean sort of top-level elements that you can then combine predicates for. And then for search, you can pass ascending or descending, and then pagination parameters. This is what the GraphQL connection spec looks like. All right, so since I said that I wanted to get feedback from the audience, I decided to kind of present what I think might be a hot take. So we are not supporting that many search parameters. We are just supporting the ones that our application developers said that they want. And I want to submit that, search, if you're implementing an interactive API, you probably should start with a very small number of search parameters and opt into them as they're needed, instead of implementing hundreds and hundreds of search parameters right away, which is, I think, the default for the FHIR spec. I think that if you need that many search parameters and that complicated of an API, you're probably doing analytics. And if you want to paginate through hundreds of pages of where each page is hundreds of elements, you're probably doing analytics. So I would like to hear what people think about that. And if you're going for analytics, you're probably going for something like SQL on FHIR. So I'm very bullish on SQL on FHIR. I think that is the way to do these types of things. And then I mentioned that this presentation is focused on read-only use cases. One actual thing with the GraphQL and FHIR spec is that there is a very tiny section on mutation, but it's very unfinished, and it says things like patch we'll talk about patch later. And I can understand why this spec was written that way, because when we were thinking about how to do mutation, we were also kind of like, we'll think about it later. And then I think one reason is the REST API for writing FHIR resources is very good. So we'll just continue using REST for writing. And then our sort of application developers are okay with that. Like it's okay for them to write and read in different protocols. One thing is that if you do something like what we did, where we have like different data stores for writing and reading, you might run into this problem with reader writes, where like the things that you write take a while to reach the server where you can do reads. If you don't do that, then you don't have this problem. But this is just something that affects us. And if you decide to do what we do, it might affect you as well. All right, so this is the end of the presentation. Just to summarize, if you're deciding if you should use REST or GraphQL, it always depends, as always. Look at your use cases, look at your data access patterns, and decide if one of them is easier for you or not. And if you decide to go down the path of actually implementing a GraphQL API, again, how to choose your tools is dependent on your own use case and your own situation. And if you want to implement the GraphQL with FHIR spec, just remember that it's in a draft. There are some things that are not that well documented, but exercise judgment. You don't have to do what we did, but if you do, let me know. I would be very interested. And then anytime you decide to deviate from the spec, you should have a good reason. Like, don't just implement dgraph because it looks cool. You have to get a reason, right? Like for us, it was because our users were saying that, oh, we really want like these Boolean operators. So I think that's it. And you can contact me on Huva or on at this email address. I'm also on Zulip. I will check it more often if people actually have messages. Any questions?
We have time for a lot of questions. Anyone? Thank you, Sonya.
Yeah, well, if people don't have questions, please feel free to talk to me later or tell us how crazy our spec is or our implementation is. Or if you have any more ideas about whether or not people should be using less search parameters and doing more analytics. Also happy to talk about that. All right, thanks everyone.